Howdy, today I'm here to talk about my quest to understand the mysterious world of node module dependencies. The good news is, in the end, it's really not very mysterious. Hopefully, by the end of the screencast, I'll have answered, what is CommonJS in relation to Node, what does it do, and how do I use it? Although I'll be talking about CommonJS mainly from a Node perspective, this is completely relevant to Sails in that you'll be using the module pattern throughout your Sails development. If you've ever looked at the source of a Node application, you've come across some derivation of the following methods and objects. Node applications are made up of modules, which are the equivalent of source text files. Actually, that's not completely accurate. A module can also be a compiled Node module file, but you know what? I'm getting ahead of myself. Each module or text source file is its own domain, and the objects, methods, variables, and classes contained in them are oblivious to other objects, methods, variables, and classes contained in other modules. They are in effect private to the module file that contains them. So how do we make different module files aware of each other? That's where the module pattern comes in, and specifically Node's use of CommonJS. The CommonJS implementation of the module pattern also protects the scope of your code to a particular module instead of opening up everything to a global scope. Therefore, only the modules that are connected in a way that I'm about to describe are aware of each other. First, a quick note on what CommonJS isn't. At first, I got confused between require.js and CommonJS. Although CommonJS does use a method named require, CommonJS and require.js are not the same thing. My understanding is that require.js was created out of a need for a module loader within the browser, as opposed to Node, which is running on the server. Anyway, don't make the same mistake I did and start reading the require.js documentation thinking it's the same thing as what's used in Node. Now on to the module pattern. This pattern consists of two basic steps. One of the steps involves requiring a module you want to include from one file, while from the other file or module exposing the stuff that you want to make available to the other modules. I'm going to talk about the require part of the pattern first. I think the best way to learn this stuff is through examples. One of the early examples we're exposed to in learning Node is creating a server using the HTTP module. For example, let's take a look at this code. I want to focus on the first line, var http equals require http. This line creates a reference to a variable to the module HTTP. This happens to be one of those modules that comes compiled with Node. Armed with our HTTP variable, we can now access everything that was exposed in that module via dot notation. For example, that's how we access the create server method. However, let's say we want to create our own module. How would we require it? I'm going to explore several ways of requiring a module, but one initial way is to use this syntax. So let's create a new file called index.js, and I'll paste our new require line into this file. Breaking this down, we have an arbitrary var named utility referencing a JavaScript file, mymodule.js, located in the same directory or relative path as index.js. So before we start using our new module, we need to create it. So next I'm going to create another file called mymodule.js in the same directory with the following code. In this file, I added a var called balance and initialized it with a value of 100. Next, I created a function addDeposit. The last two lines are the important part. I exposed the var balance by exporting it via module.exports. Now, I could have named that attribute something other than balance, but by convention, I'm going to use the same name as the actual var. I did the same thing to expose the addDeposit function, that is, using module.exports. Now let's go back to our index.js file and we'll use our newly created module. I can access the exported var and function from my module through dot notation and my reference name utility. In this case, utility.balance for the balance and utility.addDeposit for the function. Again, the use of the name utility is completely arbitrary. I could have named the reference foo. So let's see this in action. I'll go to the terminal and type node index.js to launch our module. And as we wanted, the module will return the balance before and after the deposit. Next, I'm going to expand this module to act like a class using a function as a constructor. Notice that in addition to the instance attribute and methods, I also have class variables and methods that are not exposed via the require method. Keeping with this pattern, after you expose or export the code you want to make available from your module, we'll do the other step of the pattern by requiring the module. I'm going to create a new file called index1.js. Here, I'm instantiating the account class reference using the var account while passing in a new balance for the account as an argument. The other change is adding a deposit attribute to the account instance. Now let's see this in action. I'll go back to the terminal and type node index1.js to launch our module. And as we wanted, the module will return the balance before and after the deposit, as well as the amount of the deposit itself. Next, I want to show an example of the pattern where we instantiate the account class from within the require statement itself. First, we'll create a new module named mymodule2.js. On line 1, I declare the var account and do the export of the function in the same line of the code. I capitalize the A in account to signify that it represents a class. However, this isn't necessary to making any of this stuff work. It's just strictly a convention. I then build up an object that will eventually be returned when account is instantiated. Now let's create index2.js. Notice in line 1 where we're doing our usual require, in this case by putting the arguments on the end of the statement, we're actually creating a new instance of the account class, assigning it to account while passing the argument with a value of 2000. Let's see how this works. The results this time reflect passing the initial balance in as an argument, and we have access to our instance variables and methods as expected. The last example is where we export an object directly, and I'm going to use our model in Activity Overlord found in API/models/user.js. Notice that we're taking the entire contents of the file and exporting it via module.exports. Next, I'll create index3.js, use var user as a reference to mymodule3.js, and then log some of the attributes of that module. Let's see how this works. As expected, we get back the attributes we requested via dot notation. Okay, so the last thing I want to cover is a more extensive look at where we can put modules and how to require them in these different locations. As I mentioned at the beginning of the screencast, there's a distinction between Node's core modules and our own custom file modules we've been working with. Core modules like HTTP can be referenced by using just the module name, not surprisingly, HTTP. For file modules, we have a bunch of options. So far, we've been accessing our modules via relative paths, but we could also use an absolute path like this one. You can also require a file module without using the slash or the dot slash or the dot dot slash. However, the module must be placed in a Node modules folder. But how does that work? The Node documentation has a great example, which I've included here. So in this example, we have a path. We have foo.js requiring bar.js. So Node will first look in the same directory where the file that it's calling is located, in this example, /home/ry/project/node modules. If it doesn't find it there, it will traverse up the file system path until it either finds the node modules folder and the module, or gets to the root of the path without finding it, in which case returning a module not found error. The final area I want to look at is using folders as modules. This happens when you want to provide a package or library that is organized using a directory structure with one entry point to the package or library. For example, let's say you have a new templating library called supertemp, and all of its supporting modules will be installed in the root of supertemp. You could require the library by using the following. So what are my options for the entry point or the initial JavaScript file that I want to put in /supertemp? If I create a file called index.js and put it in the /supertemp directory, Node will run that file first. I could also use the extension index.node. Finally, if I wanted to use a different name than index, you can create a package.json file using the following syntax. So let's see how that works. I've set up an admittedly contrived directory structure under this example1 folder. So we have a module index.js that requires another module, mymodule.js, in the other dir folder. Notice that the parentheses at the end of the statement, which means we'll be instantiating this function immediately. MyModule.js is just a function that logs our app is launched. Finally, we have a file launcher.js that requires the folder /super_temp. So now I'll go to the terminal and type node launcher, and we get our log message that our app was launched. So now let's go to the second example under example 2. Again, a contrived directory structure, but here instead of an index.js file, we have a package.json file. The package.json file points to my crazy naming conventions deal with it.js module. And like in our other example, that module points to my module in the other dir folder. Okay, let's see what happens. And again, we get the expected results. Okay, gang, I know that was a bunch of stuff. I hope it was helpful, and thanks as always for watching.